the stresses will be what? Negative. Compression, for crying out loud. Are we clear? Have all this information down, because this is what we call analysis. Okay. Then the next thing is this. What we see next is we have shear force in the X direction. Okay. Shear force in the what? X direction. Yes or no? Right. So if you look at X, shear force in the X direction, this shear force is going to be 2 times 8 times 10 to the power 3. Oh, sorry, should not write like that. My apologies. 2 bracket 8 times 10 to the power 3. So this is 16 times 10 to the power 3 Newton. Again, you have to visualize what is going what? What is going on to this shear force? Okay, this is so once you get the force, you have to immediately, okay, how is this going to affect my life? Yes or no? Okay, because there's a lot of layers. Companies buy software to do this. Students from McMaster, we are thrifty. What do we say? Screw the software. I will do it. That is your value. What is teaching down here? What do we teach in this course? Anyone? What do we teach in this course? Real intelligence. Are we clear? Okay. So now if I were to look at the cross-sectional view now, if we were to look at the cross-sectional view now, I mean, it should be. You have to share that joke, you cheeky sort. So we know that over here, this is our element B. And over here, this is our element A. Yes or no? Okay. So we state that Vz is equal, Vx is equal to 8 times 10 to the power 3, 8 times 10 to the power 3, and then we are going to apply thin wall we are going to apply thin wall analysis. Doesn't that sound familiar? What controls the shear flow? The major web. If 8 times 10 to the power of 3 is that way, this is how our shear flow will become. And then it will become here, and then this is our terminal, this is our terminal, this is our terminal, this is our terminal, this is our terminal. That's why I don't understand some student. Oh, Eugene, I'm not going to take term test 2. Can we move my grades all to term test 3 or final exam? Isn't it suicidal? You die. Right? So now I know what you're thinking. Okay, so you say, why is it now? Because of the orientation of the force, this is our what? Major web. So what control the shear flow is your what? Your major web, and we are going to do thin wall analysis. Can someone tell me what is the stresses at element B equal to? Yes, 0. It is at that what? Terminal, because the thickness, this is the what? The thickness, yes or no? So it's equal to what? 0. So from here, you can specify that if we look at the shear will be equal to Vx over Ixx, Ixx. Vx over Iyy Qy over T. We know that at A is not equal to 0, at B is equal to what? 0. Divide your analysis into sections, or not you'll go bonkers. Yes or no? Divide them into what? Small section is easier to what? Visualize. What's next? The next thing is our what? Going back to our diagram. Okay, so we have this. Going back to our diagram, we have a force which is 2 times 8 to the power of 3, right? And relative to the element, there is a what? Perpendicular what? Right? There is a perpendicular distance, and this perpendicular distance over here is how much? You have a distance from here to the element, and this is equal to what? This is equal to 0.6 meters. So when that's the case, what comes to your mind? There is going to be a what? A moment. Yes or no? So when there's a moment, you calculate what moment is going to be. The moment is going to be in the y direction. So moment about y will be equal to twice times by 8 times 10 to the power 3, and then the what? The distance is 0.6. So this is equal to 2 times by 8 power 3 times by 0.6 is equal to 9,600. Okay. Can you all remember your bending moment? Yes or no? You can, right? So what did Eugene teach you in bending moment? So we know that this is the moment vector and this is the moment about what? About y. Yes or no? The head of the moment vector is what? The tail end is what? I told you guys, I'm throwing the entire kitchen sink into this problem. Yes or no? You don't need to whether, oh, I can't visualize, I forget the formula. Now the axis change. I know the normal stress that we calculate used to be stress X. Now it's stress Z. What must I do? If you cannot remind your mind how the stress formation change the equation, we are what? Taking it. With this, do you need to rely on the formula? What can you see? The moment vector, the head of the moment vector is compression, the tail end is what? Visualize that's why you are here. You don't obey rules like me. If you obey rules, you become a software engineer or electrical engineer. I cannot become an electrical engineer, not just because I don't obey rules, I'm partial colorblind. Okay. When you're colorblind, you cannot see red and black, okay? But anyway. So now with this, we know, right? We know that stress in Z, okay? Stress in Z, we are going to apply the formula that we are going to do my over Iyy multiplied by x. I told you, right? The formula, whether x or y, all the sudden change, and you have to visualize. Okay. So from here, right, looking at the moment, right? Element A, Evans! Element A, positive or negative? I knew it. I knew you were like, you were zoned out. By looking at your eyes when I walked there, I knew you zoned out, okay? It's okay, Evan. So with this, we know that element A will be negative, and we know that element B will be what? Positive. Why? Because if you look at the moment vector, element A is on the left-hand side, element B is on the what? On the right-hand side. Yes. Say it again. Yep. No perpendicular distance. It's acting at the centroid. Wait, if you switch the point of view, then we see that. Now there's no perpendicular distance. You are right. I'm not saying that you're wrong. You are what? All right. Okay. So now let's pali. In Korean means hurry up. We are going to look in the YZ plane. Then you see what we are seeing. Okay? Be patient with me. Okay? So now we look into the what? YZ plane. Okay? So now we look into the YZ plane. Oh, this is so exciting. I think again I need drugs to calm down. Okay? So now we are going to visualize this in the YZ plane. Okay, so this is my X. This is my Y. No, that's not my Y. This is my Y. And this is your Z. So now we are going to visualize this in our what? And I would like to do the bending moment first. So YZ plane, and then this is our rotation about X. Okay. So now I'm going to draw the structure. Okay. And then with here, we know we have two lines coming down. I hate this freaking 45 minutes class. Give me 3 hours and we'll have fun. Right? So now what can you see? Now we are going to construct our geometric centroid again. So this is our geometric centroid. Now we can choose that this is our element B and this is our element A. Okay? And then now we start putting in the forces. So we now know that this is what? We have what? We have 100 kilonewton here. We have twice times by 8 times by 10 or 8 kilonewton here. And then we have a force down here. Wait. Am I looking at the correct view? I got too excited. No. So these are dots. Or these are crosses. Sorry, these are crosses. Right? So they are 8 kilonewton. 8 kilonewton. And then we have another force coming down here, which is what? 25 kilonewton. So now I would like to deal with moment in the what? In the x-axis. I want to deal with moment in the x. Now this is the place where a lot of mistake. Students make mistake. Okay. So what I like to do is I want to consider clockwise as positive. You decide whether clockwise or negative or is positive or what? Negative. Okay. Now you were right. Can you visualize now? What's your name again? Ryan. You are right. Can you visualize now? The 100 kilonewton is causing a moment, but it's causing a moment about which axis now? X-axis. No more like what we had before. It was on the what? On the Y. That is why we have to use what? 2D to visualize a what? A 3D problem. Or not, you will get really confused. We okay? Okay. Yep, you're absolutely right. But, oh, okay, sorry, too excited. Okay. So now we're going to calculate. Now, can you tell me what is the moment, what is the perpendicular distance of the 100 kilonewton to cause a moment? Remember, I taught this a while ago. Whenever the applied force is parallel to the centroid, you take the distance to the what? Whenever the applied force is perpendicular to the centroid, you take it to the what? The element. That's why I put everything in now. You have to what? Remember, right? Remember I told you, whenever the force, okay, I'll write this down. Whenever the applied force, parallel to the what? Geometric what? Geometric centroid. the perpendicular distance, okay, the perpendicular distance is to the what? Centroid. Yes? So this is number 1, or this is 1. The next one, when the applied force is perpendicular to the what? Geometric centroid. Okay. The perpendicular distance is to the what? To the element, right? So for this case, the force for the 100, the force is parallel to the what? Geometric centroid. So you take the distance, the moment is to the what? Geometric centroid. For the 25 is perpendicular to the geometric centroid. So you have to take what? Take this distance. Are we clear? Okay. After doing this, no more difficulty. We are done. Okay, then it's just matter of what? Throwing in the formula. I'll see you on Friday.